Hello class, welcome to another lesson. Please write down the following learning goal at the top of your notes. I can identify real numbers and classify them into their correct categories based on the definitions of natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Definitions. There we go. Remember that any number that you have learned about so far is a real number. You have not learned about any number that is not real. Okay? In the future, you'll be learning about something called imaginary numbers and be introduced to those. But as of right now, any number that you've learned about or have seen is a real number. Okay? In order to be able to accomplish this learning goal, we're going to need to know the definitions of these 5 different types of numbers. So let's get started. Please draw this diagram inside your notes. This is called the real number target. It displays the different kinds of real numbers and how they are related to one another. For example, any number that is a natural number is also a whole number. Any number that's a whole number is also an integer. Any number that is an integer is a rational number as well. And anything that is a rational number is not an irrational number, which kind of makes sense because they are opposites of one another. So if you are a rational number, you cannot be an irrational number, and we'll go into those definitions right now. So the real numbers are irrational and irrational numbers, as displayed right here. Okay? All of this are called real numbers. Okay. So please draw this table. We're going to be filling in this side of it as we go forward and referring back to this consistently. So please write down these different kind of categories. Notice that irrational is set apart from these because anything that is over here cannot be over here as an irrational number because these are all rational numbers. Okay. So the first one that we're going to talk about are natural numbers. Okay. Natural numbers were the first numbers ever discovered. And they were discovered by looking at the fingers and simply counting up. Excuse me. So natural numbers, also called counting numbers, okay, include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on and so forth. Okay. Notice how it does not include 0. Back in the day when we were very primitive, the idea of nothing, okay, being represented excuse me, by a number didn't really come into the consciousness until later. Okay. So natural numbers were the first numbers discovered, and they are anything that you can count with your fingers and up. So again, it includes 1, 2, 5, 6, 11, 100, 3,472. So going back to the chart, again, natural numbers or counting numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. So fill that in inside your table. Whole numbers. Okay. Whole numbers are natural numbers, except they add one more number. And you can guess that number is 0. The 0, and later on inside the history of human life, became into the consciousness of realizing that there needs to be a number accounting for having absolutely nothing. So it's all the natural numbers, all the ones that you can count on your fingers. Again, 1, 2, 5, 11, 25, 72, 3,466, and the wonderful number we know is 0. Okay, so natural numbers are the counting numbers, whole numbers are the natural numbers, and 0. As displayed right here. Again, fill in the table with this so that we can show that 0 is the only number added in order to make whole numbers. Now we're going to go on to integers. Integers are positive and negative whole numbers. Okay. So the concept of negative numbers came into the consciousness later on after the discovery of the number 0, realizing that there needs to be a number indicating something is owed to somebody or a number that indicates something is below something. So that includes negative 3, negative 14, 3, 0, 22, negative 49, negative 8, and 17, for example. Okay. all of those are integers. So we start with just the counting numbers, we add 0 to make whole numbers, and then we include negatives, which gets us our integers. So over here, please fill in these as well, indicating that the negative numbers were included to create integers. Now we get to rational numbers. Rational numbers includes an infinite amount more numbers. And rational numbers includes fractions, regular counting numbers, negative numbers, terminating decimals, and repeating decimals. That is, even to simplify it more, any number that can be represented by a fraction. Any integer can be represented by a fraction. So negative 3, for example, is negative 3 over 1. Any number that terminates, so for example, 1.25 can be represented by a fraction, which is 5 over 4. And any number that continues and repeats on and on, that has a repeating decimal. So for example, 0.27 repeating can be represented by a fraction 27 over 99. And tomorrow we'll prove that any number that has repeating can be represented by a fraction. Excuse me. So rational numbers again include natural whole integers, but they also include any number that can be represented by a fraction, including repeating decimals. And again, we'll show that tomorrow, that any number that repeats over and over as a decimal can be represented by a fraction, such as 0.27 repeating. So please write this down inside your chart, that rational numbers are any numbers that can be made fractions, and any number with a repeating decimal, which again we will show tomorrow that these two are actually the exact same thing. Okay. Finally, irrational numbers. So again, all of these are sort of associated with one another. Anything that's an integer is a rational number. Anything that's a whole number is a rational number. Anything that's a natural number is a rational number. Natural number is a rational number, and so forth and so on. But irrational numbers are a completely different set of numbers, but they are still part of the real number system. They are part of the numbers that you have encountered before. Irrational numbers are numbers with decimals that go on and on and on and never repeat. So these are ones that have decimals that repeat, and these are the ones that are decimals that go on and on and on and on and never repeat. Okay. So irrational numbers. Irrational numbers include the number pi. For those of you guys who tried to remember pi a long time ago, you'll remember that 3.1415 and so on and so forth. It never repeats. It goes on and on and on and never repeats. Another example of a number that never repeats is square root of 3. In fact, any number, please write this down, any number that is not a perfect square and is square rooted is irrational. So that includes square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10, square root of 11, and so forth and so on. Okay, any number that is square rooted but is not a perfect square is going to result in a number that repeats on and on and on, or excuse me, goes on and on, but never repeats, making it irrational. Okay, so these are really the two different types of irrational numbers. Numbers that go on and on and on, but never repeat and are written as a symbol, and the square roots of non-perfect squares. Okay. How I remember the definitions of these categories and which ones goes into which is by this over here. I say no way it's rational. It is. And no stands for natural numbers. Way stands for whole numbers. It stands for integers. And rational stands for rational numbers. And notice how that ends up a sentence, and then it is, okay, stands for irrational numbers, which are completely separate from these four over here. Again, all of these are real numbers. So, please write down this acronym over here, or excuse me, it's not an acronym, I don't remember exactly what it's called, but please write this down over here, and its corresponding categories. Okay? No way it's rational. It is. Okay? So, we need to categorize these into the different types of numbers. We have 3, 0, negative 8, square root of 16, 9 over 11, 9 elevenths, pi, square root of 5, and 5.301 with the 0, 1 repeating. So I want you guys to write these numbers down, write down these categories and lines next to them, and we're going to try to categorize these into their proper spots. Let's start with 3. Remember that natural numbers are the numbers that you can count on your fingers, and 3 is a number that you can count on your fingers. So 3 is a natural number. You cannot count 0 on your finger, so 0 is not a natural number. Natural numbers do not include negative 8. Square root of 16, 16 is a perfect square. And the square root of 16 is 4. And so this number right here is actually 4. And 4 is a number that is something that you can count on your fingers or higher. So therefore, that is also a natural number. Whole numbers. Okay. Remember, whole numbers are simply natural numbers plus the number 0. So anything that is up here is also going to be in whole numbers. A natural number is also a whole number, so we're going to bring down the 3. We're going to bring down the square root of 16, which is actually just 4. And then we're also going to include 0. Integers, those are whole numbers and negative whole numbers. So we're going to, again, bring down anything that's here, down here. 3, square root of 16, and 0. And we're going to look for any negative whole numbers. And the only negative whole number I see here is negative 8, so we're going to bring that down as well. Rational numbers. Rational numbers are any integers. And they include numbers that are represented by a fraction and any numbers that are repeating decimals. So we're going to again bring down all of these down here. So 3. Oops. Oh, I think we're frozen a little bit. Yeah, we're frozen. I'm going to pause this for a moment. And we are back. So we're going to bring down any number again that is an integer into the rational number category, because anything that is an integer is also a rational number, including 0 and negative 8. Okay. And we're also then going to look for numbers that are represented by fractions, so 9 elevenths, and also any numbers that are repeating decimals, so 5.301 with 0, 1 repeating, are all going to be are all going to be rational numbers. Irrational numbers. Remember, these are the numbers that repeat on and on, or excuse me, go on and on and on and on, but never repeat. Okay. This includes pi. Remember that pi is a decimal that never repeats. and the square root of any non-perfect square, including the square root of 5. So those are our irrational numbers. And notice how any number that is a irrational number is not an irrational number, and any number that's an irrational number is not a rational number. Okay. These are completely two distinct categories, just like the target would suggest. Okay. These are completely separate from one another.